Hey everyone, my name is Matt Togel and I'll be going over this Git workshop. So this is going to cover Git, the program. I'll mostly focus on the command line tools for it. And then I'll be talking about GitHub. I'll talk about how they're different or what the difference is between them. And I'll discuss how you can use them for personal projects, solo development, team, classes, whatever. So hopefully by the end of this presentation, you'll know the basic in and outs of Git and GitHub, enough to utilize it for whatever you want to do. So the goals are to learn what Git and GitHub are, uh, learn to use Git and GitHub, and time travel, just to keep the theme of this presentation. So what is Git? Well, Git doesn't really have a meaning, or it doesn't really mean anything in particular. If you want to look at the origins of Git, you can take a look at this link here. Um, the link basically summarizes, depending how you feel for the day, you come up with your own acronym for what Git stands for. The purpose of Git is that it's for version control. So version control is managing the history and metadata of file changes. We're going to be recording various timelines. Then we can always go back and forth between these different points in time and create new timeline branches. So it's basically our time machine. So if you decide to follow along with this presentation, make sure you download Git for whatever operating system you have. For Windows, we have Git Bash. Git Bash also enables other Unix-like commands, and I primarily use that over PowerShell or CMD, just because I'm more familiar with Unix commands over the Windows commands. There are various options you can use to install this. Usually the default values are sufficient. As you learn more about Git, you can always adjust those settings to your preferences. For Mac, I recommend to use Homebrew. Homebrew is an extra kind of like package manager you can install, and then you simply brew install Git, and it should install without too much issue. If you have Xcode installed on Mac, it also comes with Git. Just make sure you have a relatively recent version of Git so you can benefit from any new changes and security patches and whatnot. Linux, simply sudo apt install git or whatever your super user is. And then the last one, of course, is just part of the theme of the slide. Go along with everything. So again, I'll mostly be using CLI. CLI is command line interface. That's just because I'm more familiar with that, and once you learn the CLI, you can pretty much get comfortable with any version of UI. So there's like GitHub Desktop, there's integrations into like VS Code, Visual Studio, Eclipse, Rider, whatever IDE you decide to use. So the first thing we want to do is we want to see what version of Git we have. So we can use git space -v. So I will open up my terminal just to demonstrate. So git -v. Oops, if I can. Okay, so depending on the version you have, it might be git -- version. So during the live presentation, git -v worked. During the recording, we have git -- version. So whichever one works for you, it will show you that version. I think it's because I have a different version on my other machine. This one is a much more recent version. They might have changed things. But either way, as long as you have 2.3-ish something, like 34 or I guess even 27, even though it's kind of old, but try to have a recent one. It's not too difficult to update it depending on what your operating system is. If it's Windows, you download it. If it's Mac, brew update. If it's Linux, you can just update it. Okay, once you have this all set up, you're ready to continue. So there are two ways we can initialize a repository. And a repository is where we're going to record all of our changes. This is a very special kind of folder, and inside this repository, there's a very important folder called a .git folder. Now, .git, anything that begins with a dot in it, like a file or folder, is hidden in the file system by default. So you won't see it automatically. You'll have to do a command ls space -a to list all files, or on Mac you can do command shift dot to show hidden files, or on Windows you can go to the file browser, view, and turn on show hidden files. But normally you're not going to be messing with this folder. If you mess with this folder and you break it, your entire local repository is gone. So be careful. So there are two primary ways that we go about creating this. We can use git init, or we can use git clone. Now, since we're going to be starting from the command line first, then later doing GitHub, I'm going to guide you guys through the git init phase or steps. Normally in my classes, I use GitHub or Git and Github, and I have my students create their repository on GitHub first, then we clone it. Cloning it saves us a couple steps, but either way, it's the same no matter what you do. So what we're going to do is we're going to create a new folder for this example. We're going to initialize the repository, and we're going to practice or learn and practice a few Git commands. So let me open up my editor, my terminal again. So I have a couple things in here. This is from a previous presentation. I'm just going to do a new directory called demo, and I'll cd into that demo directory. So if I do git, first, let me just show you, it's definitely empty. So if I do git init, it's going to initialize an empty directory, and then I have that magic folder. Now, we're seldomly going to touch this folder. There's only one thing I'll have you guys edit at one point. As you get more comfortable with its usage, then you can further explore what you can do. And then I'll demonstrate git clone in the future part of this presentation. So Git is about tracking changes and creating checkpoints of progress. So we can't use Git if nothing changes. We can only record changes, and changes are new files, deleted files, edited files, things like that. And it's mostly watching files themselves and their contents. So we have a couple phases, if you want to call it that, categories, buckets, whatever word you want to use, that Git manages. So first we have our working directory. Our working directory is nothing special. It's literally where we are in our file system and where we're actually actively working. Then we have a staging area. So this is a conceptual thing. You won't actually see a folder called staging, but this is where your tracked changes are going to be kind of recorded. Your track changes doesn't mean that they're confirmed yet. They're just things that Git is currently tracking, and we'll confirm when we get to the next step. The next step will be committing. Now, committing is what persists those changes to your timeline. So if you remember drawing out timelines in grade school, every little dot or every little line through the timeline is technically your commit. And then from every little commit, you can create a branch, but we'll cover that later. So first we're going to focus on one timeline, and then we're going to learn about other timelines. So the first command I want you guys to get comfortable with is git status. Git status alone is fairly powerful. It will let you know exactly what Git knows about your files. You can read the docs down in the link below, and it'll further give you other arguments that you can pass to get more information. I'll show a few things later on too. So if I run git status, nothing exciting because we don't have any new files. But if I go and create a file which that we're going to be using for demo purposes, I'll do test.txt. So if I do git status now, we now have an untracked file that Git is detecting. So right now the file isn't associated anywhere. It is just here, and we'd have to track it. Git even tries to be helpful and give us some information on what the next step would be. So that brings me to tracking changes. So again, anytime a file changes, you have the ability to track it and then later commit that change. Then after you commit and save that checkpoint, anytime the file changes again, you can add and commit again and create a new checkpoint. Then, in the future, you can always go back and forth between the two checkpoints to see how the files changed. You can also compare between those two checkpoints as well. Now, tracking doesn't happen automatically by design. You guys might be familiar with Google Drive, OneDrive, Dropbox, etc. We don't want that to happen for Git. We want to make sure that we are responsible for recording these timelines and making sure our code is working before we do something important with it. We don't want that to auto-synchronize. That being said, you could run into issues if you have your Git directory or your folder that you're working Git in inside one of these inside of one of these auto-syncing folders like Google Drive, Dropbox, whatever. It used to be more of a problem back in the day, but they've gotten a little bit better. So if you have a reasonable internet connection, you shouldn't have issues, but it's highly recommended not to have your Git stuff inside of an auto-syncing folder. If you do, then I do recommend to either tell your auto-syncing stuff not to watch that folder or to sync it less frequently. But anyway, so there's a few ways we can track files. We can track an entire directory, like current directory. We can do git add dot. That's not usually the greatest way to do it, and depending on your version of Git, it may warn you that that's eventually going to be deprecated, I guess. You can use git add dash dash all. If you want to only track specific files, like you have some things that you're not ready to really track and commit, you can add the file specifically by full path from where you are. So you can either use an absolute path, meaning from the root of your file system, or you can use a relative path from where you currently are. And again, as I said, you can also track folders. So I kept it separate from git add dot because dot is really a shortcut, and that's your current directory. But if you want to add a specific folder in your current directory, you can do git add and that folder name. So I'm going to go ahead and add my test.txt. And then if I if I git status, then I have a new file being tracked. And then it recommends, if I didn't want to commit this, I can untrack it, unstage it. So when the file is in this mode, it is in the staging category, phase, whatever you want to call it. And there are two ways that you can unstage files. Depending on your version of Git, it may recommend one or the other. So if I didn't want to track this, or I tracked it by accident because I did one of these shortcuts over here, I can do git rm --cache, and then the path to the file. So it's going to remove it from the staging area, but it's not going to delete. Now, git rm --cached is slightly dangerous. If you forget that --, or dash cached, it will delete your file, which is probably not what you want. So let me do another example. So if I do git add, so git status. So if I can also do, again, skipping ahead, so let me get to those pages first. Before I move on though, I will try to be linking to the documentation of each of the commands so you guys can get a bigger picture. I'll be showing you the bare minimum to get started, but it is advised to go through the documentation, at least at a glance, to get a feel for what other capabilities. So anyway, I have git rm --cache, which I already ran. I usually use that one. Alright, so we're going to get back to get staged. Get staged is likely after you track it. I'll double check after we get to that step. As I said, I commonly use git rm --cache. Either way, it does the same thing. This just might not work until you have a commit history. Since I don't have a commit history, that's where I'm getting the message about head is your latest commit on your local. Alright, so I will demonstrate that in a minute. When you go to commit, Git needs to know who the author is for that commit. So sometimes it can fetch the author from the current user that you're logged in as. Usually when you clone from your repository, you have your GitHub username. If your GitHub username is close or exactly your machine's username, it'll set you as your author. I do recommend to override it to put your proper GitHub username and GitHub email as the author. Since we haven't created a repository yet, and most of you at this time of this recording might not have your GitHub created yet, I recommend to use a username and email that you're planning to register with. So I'm going to be using my NGIT stuff, which I already have set up, of course. So if I try to commit now, I'll show you that we get this message. So git commit. I'll get back to what this means in a minute. I'm just kind of skipping ahead to demonstrate something. So you get this message if it's not set up properly. So it says author identity unknown, please tell me who you are, and it gives you these examples. Now, if you want to set the username and name for all of your Git repositories or fallback for all your Git repositories, you can use the global modifier argument, whatever you want to call flag. Usually, if you're working with multiple GitHub accounts, I don't do this. I usually just set them per repository, but it's really up to you. So I'm going to do mine. So git config user.name, and this is my GitHub name. And then git config user.email, and this is my GitHub. Good. I'm not going to rerun the commit yet because I want to go over that page first. So to confirm the pending changes, the pending stage changes, whatever is in the stage phase, you're going to want to commit. Commit is going to make that little blip on your timeline. Now, a commit always requires a message, even if it's empty. So technically, you can provide an empty string as long as you have the act of giving a message. It'll be fine. However, you don't want to just use empty strings. You don't want to just type random stuff. Usually you want to summarize what you're changing because you can see the commit messages in your logs. You can see it on GitHub later on, and it's usually a reminder to yourself where you left off or what is related to this commit. That way, if you ever need to go back in time, you can see exactly what you're going back to instead of just some random characters. So make it a good habit to write concise and clear messages. If you don't provide a message when you're doing it on the command line, it's going to open up your default text editor. So the default text editor on most machines when you set up Git is VI. VI is not necessarily beginner friendly. There's usually two phases of this command line text editor. There's command phase and there's edit phase. And there's real no immediate instructions on how to use it. When it's open by default, you're already in command phase. If I'm not mistaken, you press enter to not enter. You press insert to go into typing phase. Then you press escape to go back to command phase. I also don't believe it tells you what the commands are. You kind of have to look up the manual first or some information online. So usually when you're first starting, the main command to know is :Q. :Q is to quit. You have :W to write. You have :Q, WQ to write and quit. You can force quit with the exclamation mark. I believe it's :Q exclamation, and things like that. The typing is just normal, like any text editor. It's just the commands that they're not as intuitive. I usually just go through Nano. Nano is another text editor, much less advanced, of course, but it's more beginner friendly a bit because at least it tells you the commands on the bottom of the screen. So I'll be demonstrating with Nano, but you guys can use Vi. The little comparison I usually do is Nano is to Vi, sorry, not Vi, VI. Nano is to VI as Notepad is to like Notepad++ or even the fuller IDE. Because you can install packages and do a lot more with it. But anyway, just beginning stuff, you can use whatever you like. Just make sure you add your messages so you're not surprised with what opens. There's also another instance in the future that I'll try to remember to highlight that you can run into this if you're not paying attention as well. Okay, so we're going to be using git commit. We're going to be having a message, and I'll also display git log, and you can see more functionality you can use. But also pay close attention to the git status at the end of this commit. So if I do git commit -m, adding my test file, so something clear and concise. So it's going to show us some information about what changed. In my case, I had one file change. My file is empty, so I have 0 insertions, 0 deletions. And since it was a new file, it was a create mode. Now if I do git status, everything is up to date because I confirmed my history. And now my local is at the exact history that's been recorded. So there's nothing to change. There's nothing changed. As soon as another file changes or this file changes, it's going to be eligible for staging, eligible for commit. We can create another mark on our timeline. If I do git log will show me the one commit that I have. when it happened, and what my commit message is. There's also other information you get from here, but that's beyond the scope of this we'll kind of run through. So normally you don't just use Git in one branch. You can, but normally you don't. The main, or one of the main things you usually do is you split your project up into logical features that are hopefully isolated. They have isolated dependencies. Of course, sometimes you can't get that, but usually you break down in isolated dependencies. Then you create feature branches to work on those dependencies. That way, when you're working in a team, you can split up those isolated dependencies, give one of them to each of your team members, and you guys can work on things without stepping on each other's toes. So branches are that way. So a branch you can kind of conceptualize as a maybe like a save game state in a video game. You can always go back to those branches and see where you were from that point in time, that progress. So your friends are technically playing on different save files. That way, if they make changes, it's going to just work on, it's only going to affect theirs, and it's not going to bother any other save file. So our branches are separate. We can later combine them, and I'll show you how. But first, let's get into the actual basics of the branches here. So you may have noticed that your default branch is likely main at the time of this recording. It used to be master, so you might see some old instructions online where it uses master branch. The branch name technically doesn't matter as long as you're consistent with what you're doing and you know the meaning behind the name. So main is just what you're working on by default. Normally in projects you split up separate branches for like development, QA, prod, and whatever, but different strategies for different projects and different teams. So you don't have to take my word for it. It depends on what you're doing. Okay. Oh, I forgot to show what to show. So if I do git status, it already shows I'm on branch main. Now, lucky for me, I'm using git bash on Windows, so git bash already shows my branch name here, so I don't have to keep typing. Mac and Linux, I'm pretty sure you still have to type the various commands to see where you are. There may be modifications you can do to get your editor to show. I just haven't set that up on mine, so I don't know off the top to kind of advise you on. Okay. So we have a couple ways to deal with and to make branches. So the first command is git branch. Git branch will list all of your local branches. It'll also highlight what branch is active. So let me demonstrate. It won't be super exciting because we just have one branch. So git branch. It'll show that I have main active. If your terminal supports color coding, your active branch will be green. If it doesn't, then it's going to be the one with the asterisk next to it. I'll show this command again once we create a new branch. Then we have two ways of making a branch, depending on what we want to do. So let me just minimize this so you guys can read where I'm going. We can use git branch name. So that's going to create a branch from the current history of the active branch, but we're going to remain in the branch we're just in. We can do git checkout -b branch name. -b makes it create a new branch. If you don't have -b, it's going to switch, but we'll cover that later. So checkout is going to create that new branch and switch to it. So either way, whatever version you use out of these two, it'll copy the history and it'll be like a branch of that timeline. And then you can work on whatever you want to work on. It's not going to impact the previous branch you're just on until you tell it to impact that branch. So I'm going to create a demo one or some random one. So I'll do git checkout -b, and I'm going to call this, I don't know, branch one. So I checked out, it's created and switched to it, so I'm in branch one. I still have the same file here because it's a copy of that history. If I do git status, since it's a copy of that history, I don't need to do anything special with it. That checkpoint in that history, that timeline is already there and accessible. Let me just see if I'm jumping too far ahead. No, okay. Yeah, I guess I'll demonstrate this too. So if you happen to call it by the wrong name, or if you didn't mean to create a branch, you can always delete it and rename it. So let's say I'm doing git checkout -b branch 2. Let's just say I'm making a other one. If I didn't mean to do that, I can do git branch -d branch 2. But of course, you can't do that when you're in that branch now. That branch is active, so you can't kind of delete where you are. You have to switch to a different branch and then delete the branch you want to delete. And also, I forgot to mention, so branches aren't technically physical folders that you're used to in a file system. They're like a 3D view of folders if you want to think about that. So you have your normal flat 2D file system. So like if I do ls or ls might say, I have my .git folder, I have the folder I'm in, I have my file here. So branches are copies of that. So I have the same folder structure in the branches, unless I give or take what your history is. It's just different instances. So just keep that in mind, and I'll demonstrate that in a moment. So let me first check out branch 1 and then rerun my delete command. So now that I deleted it, the branch has now been deleted. If I type git branch, I should just have the 2 branches active now. Now let's say I didn't mean to do branch 1. Let's see if it's going to let us rename the branch. I think it will let us rename it with it. So git branch -n, and I'm going to call this second. So I just renamed branch 1 to second. So if I do git branch, I have my branches here. So you can always usually recover if you make a typo. Typos are just part of nature, so to speak. I'm going to be making typos myself. It happens, so it's okay. We can always recover from them. Okay, now time traveling. We can switch between various branches, as you just saw. I kind of demonstrated those commands early to demonstrate other things, so not quite in order of what I want to go over. But anyway, there might be times where you see your files disappear or appear and you might think they're gone. If you're using Git properly, they're not gone, they're just in a different timeline. So that's probably one of the first early concern that people have when they learn Git, is that they spend all this time working, they add, they commit, they switch to a different branch, and they panic because all that hard work is visually to them gone. But it's not gone because it's just in a different timeline. The only way it would be gone is if you happen to delete or corrupt that .git folder. So I'll demonstrate how that works. We can use 2 different ways to switch between branches. You can use the logical git switch and the branch name, or you can use git checkout. They basically do the same thing, just checkout has more functionality behind it. Git switch, I'm pretty sure, was a newer addition to clear that confusion behind git checkout. But I commonly use git checkout myself, and that's what I'm used to. You can compare the different versions of, or the different functionality here at these 2 links. So I'm in git second, so I'm going to do a new test file called test2. Then I have 2. If I do git checkout main, I have both of the files here. Main sees this file as untracked because it's not been associated to any timeline yet. If I go back to second also sees it because it's not been associated to any timeline, any branch yet. Technically branch, that's a technical term. I'm just using timeline because that's what you guys likely are more familiar with. So we have this test2. If I do git add test2.txt, we now have a new file being tracked. Tracked doesn't necessarily mean it's committed yet, it just means that this branch is aware of it. If I git checkout main, it's showing that we have an added test2.txt. So it's currently tracked and the staging area is shared among the branches. So I want to go back to main. I want to go back to second. And I want to commit it. So I'm going to do git commit -m my second file. Good. So now if I do git status, everything's up to date. My files are here. But if I go back to main, my other file's gone. And this is where people run into that panic. The file is gone is because main is not the same timeline as second. It's a predecessor timeline, if I'm not saying that incorrectly. But we haven't kind of merged those times together. So main is separate and so is second. I'm working on a new feature in second, and later on I will move that data to main. Now this moving to main or moving to another branch is not a tedious manual process. Of course, there's a Git way to do it, so don't worry. But that's the biggest concern is people say, hey, my file's gone, where'd it go? You don't need to keep synchronizing every single branch as well. So normally, like when you're doing a feature branch, you complete that feature, you add commit push. Well, we'll get to push later, but you add commit, and you're done with that branch. You usually don't go back to them. If you ever have to edit that feature when you're done with it, you create another branch, usually to track that new process, so to speak. So you do like a fixed branch instead of a feature branch. You track it better. Anyway, let's go back to second. I have my two files, and this is my time. Good. Now, there's not much more exciting stuff to do on a local machine, so we are going to go and set up GitHub. It's a fairly simple registration process. They may ask you what you're planning to use it for. If they do, it's just for survey purposes. Once you get your account set up, you're going to create a new repository at the link under that plus icon towards the top right of your screen. I'll be making a new repository for this video. Oops. And find out where I put the other. There we go. So, new repository. I did one during the live presentation, so I'm just going to do GDSC video. So this is the standard setup. You could use a template if you have any templates. You might have saw I had a Blazor template here that's for another project I'm working on. Typically, depending on what you're doing, you're not going to use a template. But as you get more familiar with things, you might have templates set up. The repository name has to be unique for your account. Description is optional but recommended. Then you have the option of public or private. Public means anybody can view it. Private means only you and people you invite to it can view it. Previously, private repos were paid for. After Microsoft's acquisition of GitHub, they made private repositories free. So great for classes. So I'm going to make mine private. Then you have a couple options here. Normally, you'd create a README file. A README file is a standard file that gets displayed on GitHub, and it's a place where you can describe what your project is. You can leave yourself notes or whatever you want. I recommend to explore various other public open source repositories to kind of see what they do with their README file. Then we have a .gitignore file. This is a very important file that I'll discuss later, but you could preemptively create one. I don't want to create anything right now because I want to show you the first screen you'll see for a truly empty repository. Then you have a license. You can apply a different license to how shareable your code is or whatever. Optional, but it's a good idea to do if you do an open source project or if you just make your repository public. So basically, we just need a name and we need to determine if it's public or private. That's the main step. So I'm going to click Create Repository. And this is the default view we get. There's nothing in here, so Git tries to help us out by giving us some commands to run. And since we initialize the repository locally first, we're going to need to run some of these commands. That's this one right here, basically. Now, we already know Git init. We already know Git add. This assumes that we created a README file from this stuff up here. We know commit. We know branch, so it would rename the branch to main in this case, because depending on the version of your Git program, it might use master as a default branch. This is a step we're going to do here. So from a freshly initialized folder, we need to tell Git where to send the data. So that where to send data concept is the remote. So it's a remote machine, remote repository, remote whatever. Then typically you're going to see the word origin. Origin is just an alias for the full URL to your repository. So my full URL to this repository is this. Yours would be your username and your repository name.git. And we are going to make sure we use SSH. Previously, prior to August 28th, 2021, I think, you used to be able to use HTTPS with your username password, but that's not really strong authentication. So they're migrating people to SSH. You could still also use a special token you generate. I don't advise that personally. I do recommend using SSH keys because SSH leads on to other things that are important to know how to do. Then we are going to send the data to the remote repository. I'm going to go through these steps slowly, and I'll explain the different processes as we go. But now we have our repository. Let's find my other page here. So we want to associate the remote repository to a local, or make our local aware of the remote repository. You can have as many remotes as you want, and it might not necessarily need to be the same repository. It doesn't need to be the same repository, but you just have to make sure the history makes sense. Anyway, most of the time it's going to be the same repository. Everyone's standard projects. So if I had created a README file or something else during that repository setup phase, I wouldn't see the screen that I just showed you. So that's why I want to show you that, so you can see the command that we're going to run. So git remote. Oops, I'm on the top. I'll go back to that. So I'm going to do git remote add origin. Again, origin can be named anything. It's simply an alias. Git at github.com. I always forget if it's a slash or a colon. It's a colon first. That total slash and GDSC video.git. So if I do git remote, that'll show me that I have origin. I forget the command off the top of my head. Let me see what it is. It doesn't like L. I just forgot how to list off the top of my head, which is not great for the video, but that's fine. Alright, G, there we go, verbose. So my origin is pointing to this, for fetch and push, whatever. But anyway, if you add it, it should be there. If you need to fix it, there's a way you can also rename git remote set URL, or no, origin set URL, and then you type whatever your URL is. You can rename it if you need to. Good. Okay. So let me go back. You can read more about the command there and hopefully memorize the commands. Obviously, if you don't use it that often, yeah. Okay. So we're going to see that Git needs to authenticate us. Again, I mentioned SSH specifically, so we need to set up an SSH key. You have two different links you can use to go through that. You might get stuck at certain steps there depending on how familiar you are with the command line. I will show you another way to do it. Debatable if it's better or worse or whatever. But anyway, so first I'll demonstrate what happens. So yeah, I'm gonna have to show something before I explain it, so just hang in there. So git push origin, and I'll try to push that. And I have a key active. Okay, so it wasn't supposed to go through yet. I have an active SSH session already, and I already grabbed my key with my GitHub. I should have gotten permission denied, public key rejected, because I don't have a key set up for, or I didn't have key set up prior. I thought I had opened a new session, but I guess it carried over. So you guys will get permission denied, and we will set that up in this video. I have a ton of keys that I don't delete, which is bad practice, of course, but maybe one day I'll delete them and clean them up. But you guys will get permission denied, so we have to go through a couple steps. The setup is the same regardless of the operating system, so you can kind of ignore Windows, Mac, Linux stuff. It's just the same basic thing. The first one is we want to generate an SSH key. Now, a heads up, anytime you see a character like this, and followed by commands. This character is not part of the command. This is just telling you to type it into a command prompt or something, terminal, console, whatever. Also, this used to be, this was the algorithm before RSA. It's now legacy, and the new algorithm is ED25519. If there's a better way to pronounce it, I don't know. I'm just going to generate the key. That's all I care about. So normally you generate a key to authenticate a specific person, user, identity, whatever. So we want to type our GitHub email address here. So I'm going to do the same thing. And I will create one for mine with my GitHub email. Then we get a prompt here. So this is going to ask us where do we want to save the file. Do not use the default directory. Do not use the default that you see here. So don't just press enter. If you press enter, it's going to create a file called id_ed25519. However, that will work, but if you go ahead and create another key and you're not paying attention, you will overwrite that key. Overwriting the key makes the previous one worthless, so you will not be able to connect to anything you have set up. So my advice in all my classes is do not use the default key. Name it something meaningful. What are you authenticating? What is it for? So I'm going to be doing the path to my .ssh folder. So I do recommend keep it in an SSH folder because it helps your professor or someone else help you debug issues if you forget. So keep it in your .sh folder, although it doesn't really matter where it is. And usually you name it that it's an identity, and you usually determine what the algorithm is. But again, it doesn't matter exactly. I'm just going to call this GDSC video. The GDSC, okay. Then you get another prompt to enter a passphrase. Now, you do not need to have a passphrase on a key. I do recommend it. That way, if somebody does get your key, they still need to figure out the passphrase in order to use it properly. So I'm going to set up a passphrase for me. When you're on a command line and you're typing sensitive information, if the program is coded properly, it will not show those characters on the screen. Trust me, they are recorded, so if you feel like you made a typo, backspace until you feel okay, type it again, and then hit enter. It'll ask you to confirm, and then you'll get some information. So you're going to get some information about where the key is. So I have identification saved in this location. It also generated the public key. The public key is okay to share places. Do not share your private key. Your private key doesn't have any extension. Also, you'll know that it's .pub. So if you have Microsoft installed and you have Publisher, Publisher will think this is a Publisher file. It's not, so don't try to open your key in Publisher. Microsoft will, or Microsoft Office or whatever will complain about it. If everything worked well, you get this nice little image. For this presentation, this image doesn't mean anything. Just make sure that it shows up. Good. So we have our key, everything's great. Then, let me see if it shows. I'll be going over these steps too. We have to we have to make sure our SSH agent is active. Our SSH agent is our key holder, basically. So you can kind of conceptualize it as a guy standing outside of like an apartment building, I guess, with those different key rings for different rooms or whatever, or even a hotel clerk, whatever. He's going to hold all the keys, and anytime you want to make a connection, if he has a key on the key ring, he is going to send those keys to that service, and if that service has your matching public key, it'll let you through. So this is your private key. So I will go over that next, but yeah, I'll turn it on now. Okay, so I already have mine active as you saw earlier, but if I didn't, I'll do eval $sign agent EXS, and that's going to show my agent is active. Now, as long as you get any PID, that's fine. The PID does not matter. The PID is process ID. So if I rerun it, I'm going to get different process IDs. It doesn't really matter. It just means it's active for me to use it. Then we use ssh-add to add the key to the key ring. So if you forgot where your key was, you can do this command. You can list the keys in a .ssh folder in your home directory. I have a ton of keys, so I'd rather not list that on this video. Not that it really makes a difference, it's just I don't need all those keys. So I'll do sh add /.sh, and I think I call it GDSC video. So when we add our key to the keyring, we add our private key. We'll use the public key in a bit. Now, since I used a passphrase, it's going to require a passphrase. If I type in the passphrase correctly, it's going to say, hey, this identity was added, and this identity is for my email. Good, that's one step out of the way. But how do we tell GitHub what our key is? And if we go down here, maybe it doesn't show it in this link, so we go to the next one. Okay, so this one usually tells us to use clip. You may not have the clip command on your system. I don't even know if I do, because this is an emulator basically, so I don't know if it's installed. Oh, okay, maybe it's installed. If it's not installed, you can use cat. Cat outputs the data to the console. Again, not super recommended, even though it is your public key. You do want to try to keep things like private, and I don't recall if that shows up in history or not, but again, it's public key, so debatable how bad that is. So for this video, I'll use cat, and I can do .sh, GDSC, and I will do video. Now be very careful that you don't just run this. If you run this is going to show you a private key. I will create another key, I'll show you what happens, and then I'll delete it in a minute. But anyway, we want the .pub one. So that's going to show the algorithm, the hash, and who it's for. So I'm going to copy this so I have it for later. Now, just to demonstrate real quick what happens if you show your private key, let me just rerun this. I'll create it in this directory, so I'm just going to call delete me. No passphrase because it'll be deleted. So I have this delete me key and delete me pub. So if I mistakenly show the wrong thing, this is the private key for this key. We don't want to share this because this is like giving somebody our house key. So I specifically made a key not to show the one I'm using, just in case I delete it. So anyway, don't use your private key at all. I'm just going to delete that. And I don't know why it's taking a while. Good, okay, just getting rid of that to show. So after we have our key, our public key copied, we go to our GitHub. Open over here. We go to our account, go down to settings. We go down to SSH and GPG keys. We click new SSH key and you give it some meaningful name. Usually you give it the name of the machine that you're accessing it from. So your keys are per machine, per repository, typically. You typically don't share keys across machines. That way if it's compromised, you can delete the compromised key and still have access to the other one. So I'm going to call this GDSC video, delete, just so I hopefully remember to delete. I'll paste my key in there. This is my public key, and I'll click add SSH key. It usually asks you to authenticate, so I have two-factor set up, so just hopefully it sends me a message. And then it's going to approve and add that key. So the key gets added to the bottom of the list. I have GDSC down here. It's added on this date, and it's never used currently. Good. So once that's all set up, and once my SSH agent has it, I should, have access to GitHub. So that's when this command should have worked. Now, since I already had a key active, it worked, and I can't push again because it's the same data locally as remote. So I'd have to make changes in order to show more changes. So since I already had pushed it, let's take a look at where it is. I'll just go back. I'll go back. Okay, so it's showing up here. Now I only have one branch here because I generated an empty repository on GitHub, and I only pushed my second branch. So the first branch that gets created on GitHub becomes a default branch. Um, Default makes a difference in some cases. I may not discuss that too much in this video, but we'll see. So right now I have this second branch. I can also go back and do git checkout main, and I can do git push origin. So if I just push it, it's going to push the history from local main to remote main. Typically, when you do these commands, which I'll cover in a bit, you do it from the same local branch to same remote branch, same remote branch, to same local branch. So now if I refresh, because it didn't live update, I should now have main and I should have second. Now I'm going to take a minute, I'm going to change my local branch. So I'm going to go to settings, branch, and I will switch this to my default branch to main, and I'll explain that later. So now I have main as my default branch, and I have second as my other branch. Cool. Okay, a lot of slight deviation, but that's okay. Okay, so I already did this. This is just catting that command. I usually talk about using cat instead of clip because most people don't have clip installed and it's beyond the scope of the classes to install clip, just use it once. The next thing I recommend, and why I recommend it. So we're going to be making an edit in the config file in the .git folder. Normally, your SSH key is active per terminal session. So if you close your terminal and reopen it, then you have to do the eval command again, usually, and then you have to do the SSH command again. Now, if you want to avoid all that hassle, you can tell your specific project which key to use each time. That's another way of using different accounts on the same machine without too much complaints from Git. So let me go and show you how we do this. Again, I'm going to use Nano for this because it's easier to get started with, but if you want to use VI or something else, you can. So I'll do nano.git/config. Now, of course, this is only going to work if I have the .git folder immediately here, otherwise you have to use the correct path. Nano.git/config. So we go to core, we add a new entry, we do ssh command, command, and this is going to be the command that's going to use anytime Git does ssh requests, whatever. So ssh -i. So ssh is a command, -i tells it which identity to use, and we want it to use the one we just created, this one. And this would be our private key. Same thing we added to the SSH agent. Now, this will 99% of the time use this key. Sometimes the SSH agent isn't running, so you have to use the eval command to kind of like wake it up. But it should work most of the time. So good. I'm going to do Control X to save, Y to confirm, Enter to save it to that same name. So if I close this terminal and reopen it again, it already have that key active, so I don't have to do all that mess again. Good. Now we can probably talk about git push and git pull, even though I already demonstrated one of them. So again, Git does not automatically synchronize things. This is by design. So we have to synchronize the histories manually. So to take data from our machine to send it to a remote machine or GitHub, we do git push origin and the active branch name. As far as I can recall off the top of my head, you can only push from the active branch. There may be other parameters you can use, but it's really edge cases for your standard usage. This is going to synchronize that history from your local to your remote. And you have to push, I mean, you can push as frequently as you want, only if there's changes. But if you make changes after push, you have to push again. So you always have to do these 3 steps frequently. Git add, git commit, git push. The more you commit, or the more changes you make and you commit with them, the more timeline you have you can go back to, and you have different points you can recover from in case something happened. And you have more comparison points. So I already pushed my 2 branches. I can't push them again until changes happen. I'll demonstrate git pull, I think, in the next slide. So git pull takes the data from the remote branch and pulls it to our local machine. This is how we synchronize remote changes from remote. So we will be combining timelines branches in the future. So normally we would merge the timeline or branch from one branch to like main or dev or something. We'd locally check out that main or dev, then we'd pull the changes to update our local, and then we'd create a new feature branch from the up-to-date code. Um, Depending on what you're doing, if you don't have the latest history, you will run into issues when you try to synchronize later. So one key part of Git is keeping things in sync. If you don't keep things in sync, bad things can happen. And the more branches, the more remotes you have, the more people working on it, the easier it is to get out of sync if you're not doing your job. Now that seems scary, but it's just meant to make sure that you guys memorize and do the add, commit, and push process and pull process and everything when necessary and understand what each step does. If you're not careful, you can cause conflicts. Conflicts are not fun to resolve. They're not impossible, and your editor is going to make them relatively easy, but we want to try to avoid them. Sometimes you can avoid them. It depends on what really happens. For the most part, though, we can. So normally, when we're combining these timelines, you can think of like bridge shuffling a deck of cards. You can't have two cards in the same slot. So same thing with Git. When it's doing like line by line comparison, you can't have two changes on the same line from different histories. Git is going to prompt you saying, I don't know which one is supposed to be here. Tell me. So Git gives you the job to say, okay, I meant to have this data here. So the conflict occurs is when Git can't determine which piece of code belongs in that line. Now, there are different merging strategies that can be used, but this is mostly for the default merging strategy. I believe it's called rebase off the top of my head. I don't remember if it's still the default, but we'll see anyway. So we have to resolve that. Now, when your branch is in merging, usually you can't do anything else until you fix that merge. So in the next slide, I will be showing you how to create a conflict and how to resolve a conflict. That way you see what it looks like first, and then hopefully avoid them in the future, or at least know how to address them. So when a conflict occurs, we're going to get a lot of random characters, quote unquote random because they do make sense, random characters in your files. These files are going to separate the two different commit histories of what's available. So you're going to have greater than signs, equal than signs, less than signs. The equal signs are your dividers between the choice. So you have one from one commit, and you have one from another commit, typically. And then you choose which one is correct, or if none of them is correct, put the proper text. So part of the cleanup process is to delete those special characters, but you're responsible for putting the file in the proper state. Let's see. Just making sure, yeah, we must edit the file. So we're going to demonstrate this using this checklist. These are the basic steps that we're going to run. Again, this is just showing you that it's a command in my presentation. And we're going to simulate that and see how fun it is to fix conflicts. So I will keep this on the side a little bit, like here, just to keep out of the way so you guys can see the commands as I type. So I'm going to do git checkout. Actually, I'll first check out the second branch just so I can have more stuff to show later. I'll do git checkout -b to create a new branch and call conflict simple. It's very important to try to commit to whatever case sensitivity you decide to use. Just as a side note, Git is not a case sensitive program because it has to support operating systems that are not case sensitive. So if I'm not mistaken, Linux and Mac are not case sensitive. Windows is. So there is a difference between capital C and capital S for conflict sample, and lowercase c and lowercase s. Same thing for files and folders. And it is a bit of a pain to fix case sensitivity rename. It's not impossible, it's just a pain when you're starting out. So make sure you're consistent with your naming, otherwise you're going to have some weird issues down the line, because ultimately it's case insensitive. But anyway, so we're going to create a new file. I'm going to use nano for this. So if the file doesn't exist, then use nano, vi, whatever. It's going to create the file when you save it. So I'm going to say hello. Actually, let me go back. I'm going to save it. First, I'll show you line numbers. So -L. I want to show line numbers. It's important that when you do this, you edit the same line for this to break. So if I say hello, that's my first one. I have line 1 with hello. I'm going to save that. Control X, Y, enter. If I cat readme, it's going to show that we have hello here. Git status, we have a file to commit. So I'm going to do git add readme.md git commit -m my sample file. Also, if you see this on Windows, typically, don't worry about it. Different operating systems have different ways of determining when a line ends, and this is just conversion that Git would do. Git, I think by default, or at least the way I set it up, converts everything to Unix line endings. So that way, if I'm on different machines, I don't have weird stuff happen. Alright, so git status, everything's up to date. I'm going to do git push origin conflict sample. That's capital C, right? Yeah. Okay. Good. So I just pushed my new branch there. If I go and take a look at that, I have to refresh, I guess. We have a new branch that showed up. So I can either click it here, or I can click it from the dropdown. Either one works. So we have readme, we have test, test2. I'm going to go here, and I can see that we have our hello. Now, let me just make sure I'm not jumping too far ahead because I already know the steps. We're going to check our branch. We're going to edit the file and change line 1 to something different. We're going to do that step now. I'm going to edit, and I'm going to change this to world. Hello world. Now, when you're doing a commit on GitHub, if you leave this blank, it's going to use an empty string. It's still a good idea to keep a commit message here, but it's not going to yell at you if you don't. So I'm going to just say editing readme. Then I'm going to commit changes. Good, so I have hello world. Now if I take a look at readme again, notice that it's still hello. Git doesn't automatically synchronize it. So keep that in mind, that's really important for this thing. Now we're purposely not going to synchronize things just to show what happens. So we're going to open readme md locally. We're going to make another edit locally different than what's on GitHub. And I'm going to say howdy. So I'll save this, Control X, Y, and so again, this is what we have. We have howdy now. I'm going to do git status just to show you that we have a modified file now. So git add readme. Git status again just to show you we're now having a modified file. Git commit -m. Now we have one file changed, one insertion, one deletion. We deleted a line and we added a new line. So I'm going to try to do git add, git push conflict sample. Oh, origin because I forgot. Conflict sample. Now this is the first scary message that we get. Scary because people don't like red error messages. This is the most common error message that we get in the beginning, and it tells us basically how to solve it. So we're going to break this one down so that if you see this again, you know 99% of the time how to fix it. So it's rejecting our push. It said failed to push some refs to GitHub, and this is where we're pushing it. Updates are rejected because remote contains work that you do not have locally. This is usually caused by another repository pushing to the same ref. Well, the other repository pushing to the same reference was GitHub. GitHub was pushing to its own repository. Its local repository in respect of the GitHub. It's our remote, but GitHub's local. You may want to first integrate the remote changes, and it tells you probably want to git pull. Git pull takes those changes from remote and pulls them to your local. You can read more about fast forwards and stuff, which I do recommend. That's usually an issue that comes up later. But anyway, git pull 99% of the time will fix your problem. You obviously can't continue until you pull anyway. The other 1%, hopefully, time that we do it, it will have a problem. So I know it's going to have a problem. I set it up to have a problem. So let's take a look. Git pull origin conflict. So we're pulling from remote sample conflict sample to local conflict sample. That's going to pull the changes, and this is just information about all the transfer. This is different commits coming in. It's going to try to auto merge README, and we have a conflict. So it's going to tell us which file or files we have a conflict in. Auto merging failed, fix conflicts, and commit the results. So it tells you what to do to fix it. So if you're on Git Bash, you'll see that this big merging message comes up. So we have to fix things in order to continue. Let's see what a merge conflict looks like. I almost forgot what the file name was. So this is a merge conflict. We have two line, let me exit real quick. We have, oh, it doesn't show correctly. Technically, we have two choices on the same line. One of them is howdy, and it's from the commit head. Head is our local latest commit marker, I guess, for lack of a better word. The equal sign is dividing the two choices, and hello world is coming from this commit. This is a hash representing the commit on GitHub. GitHub only shows a subset by default, so you have to look for like the last 4 or so characters. But this one is from GitHub, this one is from local. We have to tell Git which one is the correct one. Now, either of them may not be correct. Maybe we want something totally different. So we have to edit the file to be in the correct state. And this is just for one line. So you really want to avoid merge conflicts because they will break the code. These characters will break whatever code you have until you resolve it. And if you have that among multiple files, multiple times in the file, that's not a lot of fun to resolve. Now I'm using Nano. Nano doesn't provide any help out of the box to fix this. Your editors usually will have little words above these saying like accept incoming, accept local, current, whatever, accept both, reject both. So they have little buttons you can click or links you can click to kind of quickly make that choice. In Nano, we just have to delete it ourselves. So let's say I don't want to have any of these words. I want to have welcome to Git. That's what I want. That's my state. So I'll save the file, press Y, enter, and I'll show the status. Now we have both modified, but how do we have both when we just have one file? Well, the both modified is a 2 different kind of timelines, sort of. Well, not really timelines in this case, it's the same branch, but 2 versions of that same branch. So it's like a weird split we have going. That's why we have both. We have the incoming change and we have a local change. It doesn't mean we actually have 2 README files, but we did fix what we need to fix, so we have to add, commit, and then after committing, it's all resolved. So git add README, git commit -m fixing mess, and then our merging warning goes away. If I do git status, we're up to date. Now, usually you don't just let it sit on your local machine. You fix it, you push it to GitHub to have that history. To do that too. Git push origin conflict. There we go, conflict sample. And if we jump back to GitHub, GitHub should be synchronized. If I refresh this page, it's the same branch. And welcome to Git. And we just fixed our first conflict. So a lot of fun to fix. Obviously sarcastic as it can get really bad. But we want to try to avoid that by keeping things in sync and updated. Okay, let's go take another look. Good, so we finished all that. We're done with the simulating Good. So that's pretty much where I left off in the actual physical presentation. I'll be wrapping up the rest of the slides um, in this video. So GitHub offers a number of features for tracking work and working with the team. A brief summary of the things we're going to be using is GitHub issues, which are basically like sticky notes but digital. GitHub or Git pull requests. This is a way to merge two branches and have a conversation about it before that merge is completed. You could technically merge on a command line with git merge, but you lose on recording certain things. I mean, sort of. Again, depends on your team and how you use it, but I do recommend use pull requests to record more information, so like you can show screenshots of it working, have other people easily review and give feedback. And we're going to take a look at these later. Then we have a project board. Now, project board has changed slightly over the recent months. As of this video, project boards used to be associated to the repository directly. So if somebody had access to your repository, they had access to the project board. The downside is you couldn't really make your project board public. Now they have this new project board, I think it's still called project board, where it's not associated to your repository, and you kind of link it in a maybe odd way. I don't know. I'm just not familiar with it yet. And you can have a public project board and still keep your code private, if I'm not mistaken. Again, I haven't really dove too deep into this, but I know the gist of how to show you what I want to show you. I'm used to the older classic project board, which I don't think you guys will have access to. You only have access to the classic one if you already had your project use the classic one. And then even then, I think they're going to, they're probably going to like deprecate that same too. Anyway, project boards to visualize these issues, pull requests, tasks, whatever. So each team and company may have different interpretations or usages of these tools. I'll cover common use cases in the following slides. The main goal is to isolate your changes in branches, as I was just describing earlier, and to reduce potential impact on anyone else's work. Now, that doesn't mean by creating separate branches and then blindly merging to one source means you're going to be safe. You still need to have sort of a code review process and just be aware of what's happening. And we're going to use the tools of GitHub to help make sure we don't break things. Okay, so first we have issues. Issues can be created from the Issues tab or directly from a project board. An issue looks kind of like this. We have a title of the issue, we have a description. Technically, this is our conversation area too. So we have a fairly nice WYSIWYG editor. What you see is what you get. It's Markdown editor, so you don't have full control over how it works, but you can always click the preview tab to kind of see what it looks like. You can be as styled as you want. Of course, the clearer you can represent information, the better. As a quick aside, we're not going to be setting one up, but as a quick aside, you can create templates for your issues. So you can have something already kind of pre-populate, and then you have users fill in editable parts of that. But anyway, the other part is you can assign the issue to people working on it. So if you're working on a team or a class, you can clearly show who has responsibility of the topic. And that person or group of people are technically responsible for completing it. You can also have different labels for your issue. So you can organize it better in your project board, and you can filter and whatever, all this stuff. You can associate it to a project board, which we will be doing. And you can also use milestones, which I won't really be going over. Milestones are just another way to group and organize yourself. Then down here, personally, I haven't kept up with the latest updates per se. So this used to be called pull requests, if I'm not wrong, and this used to be able to link an issue to a pull request. And I'll talk about a pull request later. It is and why that was important. Now it's slightly different, but you can still get the same benefit. So let me go and create an issue. So go to issues, and I'm going to say new. Let's say my first issue. This, let me just do this is cool. So Markdown, we have a nice heading, and we can say I'm learning Git preview, and we have our little issue. Then I am the only one in my repository, so I can assign it to myself. Usually you would assign it to yourself to keep up good practice, but anyway. So you have different labels you can apply. GitHub has a few built in. You can also edit labels and create your own. I'm going to use the one for good first issue. Now, I have projects created already that are associated to my GitHub. I'll be creating a new one later, so I will show you how to assign this later. Milestones I'm not going to bother with. This we can't do until we create, so I will show this later. So we submit a new issue, and then it's open. So open green is open. Open means it's still in progress. Now you can have your team or team members go here, discuss. It's a great place to upload like files of evidence. So usually what I do is I have people show me that it's working. So you can either do that with like a screenshot, a GIF, a video, or whatever. So just a quick little demonstration. If I use my snipping tool or whatever it is in Windows, I can grab a screenshot and directly paste it in. It automatically gets uploaded to GitHub and they give you this link. The thing to note, this link is public, even if you have a private repository, if I'm not mistaken. This can be beneficial in some instances. I use this to for homeworks. You can preview what that image looks like, but make sure you commit it so it definitely persists that image. You can add whatever you want here, basically, but you would show that your feature is working, and then a team member would review it. Maybe they check out your code. They should probably check out your code. And then they would say, I don't know, approved. So you want to have a timestamp of when it was approved and who it was approved by. Then, when that approval is done, you can close your issue. Closing an issue is completed, done, closed, fixed, resolved. You can also use these keywords to automatically close it, I believe. You can also close it so it's not like implemented, not used, or whatever. So you have to choose the proper one depending on what's going on. Typically, you're going to be using this one. Closing an issue doesn't do anything. It's like marking your sticky note done. It makes more sense on the project board because the project board has some automation behind it. I don't know if you have to activate it now. In the past with Project Board Classic, you had to activate the automation. So when you close an issue, it would automatically go to your done column. But I'll demonstrate that shortly. Let me just not get too far ahead of myself. Okay, cool. So the next one is Project Board. So again, this recently changed. I'm going to be going through this one. I'm not as comfortable as I am with this one as I was with the previous one due to just not getting to explore the changes as much. So we're going to go to the project tab and using the green button, we're going to create a new project. I usually select the board option, but if you guys like tables better, that's fine too. There's also a couple different templates you can use. I think feature template's more the common one, but you can also use team backlog. I haven't gotten to explore these. In the classic project board, it used to be called automated Kanban. So automated Kanban, you have your to-do column, you have your in-progress column, and you have your done column. And then there are certain things that Git does that automatically moves your items for you. But I don't know how that works with the new one because I haven't gotten to explore it thoroughly. So we're going to be using the board one. I recommend that. I personally like the board one to kind of see that things shift and see what I have to work on and not have to work on. And anyway. So issue items are your sticky notes, but you can attach a whole bunch of things to them. You can have generic cards, I think they're still called. You can have your issues, you can have pull requests. I think you can also associate milestones there and a few other data types. And they probably expanded it more in the new one too. You can also easily drag and drop them between different columns. So I usually use this for most projects, and since I already have my students using GitHub, I use the built-in project board for tracking things. So let's go and take a look. We're going to go to projects. You can go to link a project to the repository, and you can do a new project. I recommend a new project. You may have the default of new project if you don't have any other projects active. So it seems that new project boards can relate to multiple repositories, which makes I mean not yeah, repositories, which makes sense. You can track things at a higher level now. Oh, well, you don't just select it; you have to click the button too if you're paying attention. So pick whatever layout you want. I'm pretty sure you can actually switch between the two nowadays anyway. So I'm going to click board and click create. And we have our to do, in progress, and done. You can add as many columns as you want to. In the past, there used to be little cards here explaining how to use it, but it looks like they don't have those cards anymore. So I'm not going to add anything special. You can also rename your view, so you can have different views to track whatever you want to track. Git is flexible for you. So you have 3 visible fields, 5 hidden. I have no idea what those 5 are. Column field, status, count, blah blah blah. You can customize this a lot. I'm going to rename this and say demo. Good. Then we can add an item by clicking add item and just say whatever we want. So my example project board item. Just hit enter and it's going to create it. So by default, this isn't anything special as far as I know. You can convert it into an issue. So if you want to create an issue from here, you can. And you can select which repository. Do the GDSC video repository. So if I go back to getting back there is going to be fun. Let's see if it shows in the drop down. That's all my pull requests. Let me go back to my dashboard. I don't know the shortcut to get there. GDSC, and let me grab this one. So now I have a new issue that's created from that project board. So I still gotta get used to the new navigation. I used to be able to just click the bar here because my project shows up here. So you used to be able to go and click wherever you want in your repository. Now it's a little bit different, so I just gotta get accustomed to it. Anyway, so I have my new issue here, but you notice I don't have the other issue. So I can click the 3 dots here. I guess not. I don't know how to add the issue that we have already from this perspective. You used to be able to add existing issues here. I just don't remember. I don't know the new place to do it. But we can go back here. We can go to issues. Go to my first issue. And if we go to projects and click the gear, we can. It's still untitled, so I don't know which one it is. Let me give it a title. Toggle GDSC video demo. There we go. Let's see. I have to refresh because why would it live update? There we go. Alright, this is the project where I want to add it to. So you have the check mark. You can add it to many different projects. You just want to move away to get it. Then you can determine which status it's in. By default, there's no status. Let me see what it shows up as with no status. So it's okay. So one of the hidden columns is no status. So you can either pick the status to change it to, or you can just drag and drop, and it's going to go to do. Normally, when you use this issue to do system kind of thing, as soon as you start working on it, you move it here. And normally you like record some information like, hey, start doing this at this time. The whole idea is to record as much history as you can. That way you have more accountability for things, and if something happens, you have your evidence of when you started doing things. Then when you're done, you slide it over to being done. If you have automatic stuff set up, it would automatically close the issue. See if it opens up here. You can click it to open up your editable area. What am I looking for? So you can close it from this perspective. You can close it from the other issue item. Normally when issues are done, you close them. And typically you don't reopen issues. Again, it depends on your team and how they do it, but typically you don't open issues. You create a new issue and reference the closed one. And then you discuss whatever you fix you're doing or why you had to make a new issue for it. Alright, so I'm just going to move this back here. And it's all good. Let's go back to the slides, make sure I'm not jumping way too ahead. Created a new item, already demonstrated that. 3 dots, convert to an issue. I guess item is issue, color coding, yeah, okay. As I said, we can also merge from the command line locally, but then we lose this whole conversation area that I'll show you soon. So if you need to do a quick merge without anything really to be recorded, you can just do git merge from the active branch and mention the source branch. Of course, if you're intending to merge to a different location than the source branch, you have to switch to it first. So normally I have people do pull requests. Pull requests are GitHub's representation of a merge, and you can track a lot of things there too, similar to an issue. Yeah, so let's go ahead and merge our pull requests. Merge our branches. So if I go to pull requests, I don't have anything open. Git is trying to let me know that I do have branches that are different from my default branch, and it wants me to make pull requests for them. If you don't intend to make pull requests for them and you want to get rid of that, you can click compare and pull request and create it and then close it. I want to make a pull request for this, so I will go through the steps. So this is going to be my title. If you don't have a title, you can't create a pull request. So sometimes when you go to create a pull request, the title is not pre-filled and your button is not clickable. Simply just make sure you have a title. Then you can leave a comment or whatever. You can assign reviewers, so you can have other people review what's going on in the pull request. It's another place you can record information. Depending on your team might use issues, your team might use pull requests, they might use a combination, or maybe they might not use any of them, but probably should. You can assign pull requests to people or yourself. This is who is responsible for reviewing it, making sure the merge into the other branch works. You can assign it to a project, so it can show up on a project board. Depending on a team, you show either issues or pull requests. You usually don't show both because it's kind of like repetitive information, but anyway, it's up to the team. And then you can do the milestones as well. We have the whole conversation area as I said here. One thing to note, your base branch is where the changes are going to go when it's done. Your compare branch is the source of those changes. So for us reading left to right, it might be a little confusing. Just pay attention to this arrow. This is the direction that the changes are going to be going. That's another first little caveat here when you're learning Git is that where you want it to go is on the left and where it's coming from is on the right. But again, shouldn't be too big of a transition. So I'm going to create this pull request. It's going to have a lot of things here. So for one, it's going to show the commit messages. So these are all the commit messages I did. I can click into them for more information. I can also go to the commit tab to see the commits. I can copy the hash that represents the commit. I can compare the entire repository at this point in time. So the more commits you have, more or less, the more points you can compare things from that point in time. Checks usually come into play when you have GitHub Actions or CI/CD, continuous integration to continuous deployment. You have different checks that run automatically to make sure or reduce the chance that you'll have problems when you actually complete that merge. Sometimes you can even auto deploy. So like if you're in my IT 202 class, we usually use Heroku. Heroku can use GitHub Actions to deploy, but we usually use Heroku directly to do it. Anyway, you can use GitHub Actions to automatically deploy to different servers. Where there's a will, there's a way, basically. Not going to highlight too much of that because that's more of an advanced concept, not more of this kind of getting started. You can also see the files changed in this pull request. So I have my README here and I have my test2. Test2 is empty and README has welcome to Git. You can also open and view the entire file instead of just what changed and see what's going on. Let me see, there should be other things too. So if you're assigned as a reviewer, you can also mark the files that you're reviewed for tracking purposes. You can also explore other options here to comment, approve, reject, request other changes. So you have a nice workflow to work with. when you're working on a team, especially if you're like above a junior developer helping out a junior developer, or if you're just two junior developers um, helping each other out, or whatever. It's always good to have another set of eyes go over your code and make sure everything's all good. Okay. There's a lot of other cool things you can explore, but I'm not going to highlight them for the sake of the length of this video. Good. Okay. So, oops, I want to go back to pull requests. So if I close a pull request, then nothing happens. No merge happens. It's just gone. So if you mistakenly open up a pull request and you didn't mean to, just close it and no harm done. As soon as you click this and the confirmation, it will merge the data. If you see, I guess it doesn't show up here anymore. I think before up here there was like a green check mark. So if you see green check mark, green down here, green here, that means it should not have a problem if you merge it. Now you could see different colors here, and different colors mean different things. Most commonly, it'll let you know that you have a merge conflict. So if you do have a merge conflict, most of the time Git's pretty good about enabling a button that's about here that lets you resolve the merge conflicts directly online. If you can't, then a quick way to do it would be to follow there's usually a link that pops up showing you commands, or you can pull the changes from the destination branch into your source branch and then resolve the conflicts there. But that can have other issues too. It depends. The main point is just try to avoid them, but Git will try to guide you through how to resolve them. We don't have any conflicts, so we can go ahead and merge a pull request. So you record your final message, and you can hear approved, close, whatever, and confirm. If it's closed, it should be purple. I forgot to show you something else, but anyway, I'll create another pull request just to demonstrate that, but it's not going to work for a reason I'll show. You could revert a pull request. Be very careful with this unless you know exactly what this does. This might undo more than you think it'll do. So try to refrain from doing that if you can. Definitely read about what reverting does and understand the consequences if you do so. You can also delete the branch. So if you don't want it to show up here, you can delete the branch. Usually you can undelete the branch if you didn't mean to delete it. But usually it's used to clean things up. And normally you don't go back to feature branches, but it depends on your team again. So don't just blindly delete things on the repository. You can delete things locally. As long as the branch still exists on GitHub, you can always pull it back again. So debatable what you want to do on GitHub. Just speak with your team or whatever. Just be careful about deleting things that you may not know how to recover. Let's see. I just want to make sure I'm not jumping too far ahead of things. We did that. Yeah, the green. So green is good, able to merge. Oh, so there may be times where you see a red X here. Red X doesn't mean you can't create a pull request. It just means that you won't be able to merge the pull request until you fix changes. So just because you see a red X here doesn't mean you're not supposed to create the pull request. It just means you can create it, but you have to fix something before you can complete it. So this happens in my classes a lot because people aren't keeping things in sync. It's early on usually. So make sure you create it and then resolve the issues, and then you can go and close it. Good. Destination source I already mentioned. What I want to show you is that we can link issues. So let me go and create a new pull request. I probably won't be able to do this one. So second. Yeah. So usually if this is live, I'd ask, why can't I do this? The reason being is that second's history was already in conflict sample. Since we merged conflict sample into main, main has the same history that second does. Second is an outdated history, so I can't merge it. So I would have to go and change something. So I do git checkout second, and I do nano test.txt. Then I'll do git add, git commit, git commit, sm, test git push origin. Okay, good. So now if I refresh, now I have a change recorded and I can merge. I'm going to create that pull request. I'll create this. And then what I wanted to show you is from development. So we have our two issues here, so you can link the issues. So I'm going to link my first issue. Actually, no, I'll link this one. Example. You can link as many as you want. I don't think there's a limit anymore. Limits used to be like 10 for each category, but I think it's gone. So let's see if it tells me here. Browse approval, continuous integration not set up. Okay. Hopefully the new project board works a way that similar to the old one. Since I'm merging second into the default branch, any issues that are attached when I merge this will automatically close. So I'm hoping it's still the same. We'll find out. So this closed. Okay, good. It automatically closed my issue too. So that's usually what we want. We want the attached issues, our to-do items, to be associated with the actual code change so that when we actually merge that code change, it automatically closes the issues for us. That's a good benefit, and it does save a lot of manual effort. So let me go back to my project board, refresh. It even moved it to the done column. So it looks like that the newer project boards are a little bit more stable than the classic ones, at least setup wise. So that's good. Fantastic. So I do encourage you guys to leverage this. It's less manual labor of moving things around when you can attach your issues to your pull requests. And then when you merge a pull request, it's done. Now this, in the past, this only worked if you're merging into the default branch. I don't know if it's still the case. So if you're like doing a dev and a prod branch and prod is your default branch, it might not automatically close when you merge a pull request into dev. I mean, it might not automatically close when you merge the feature for branch into dev. And in the same scenario in the past, if you tried to merge that dev into prod, it wouldn't see that second hop, so it wouldn't automatically close the pull request or the issue in that case. I don't know if that's still true today. I haven't got to explore that, but just keep that in mind. It might only be the default branch. And that doesn't necessarily mean you need to make dev your default branch. It just means you just have to, be aware of how it works. Okay, cool. That's a lot. Again, one of the best part about Git is about the commits and the diffs. You can always compare between two commits exactly what changed line by line. You can even see who edited things line by line. There's another command that I'm not going to demonstrate, but you can learn about called git blame. Git blame shows exactly who did what. So if something happened to your repository, you can do git blame and see if it was you, somebody else, or what happened. So Git makes a great tool for just keeping track of all this change, all this history. And if you have a class or a project where it makes sense to have a history, we have to see exactly who worked on what, who worked on things, who's responsible for things, and keep track of all this over a semester over the course of the project. I do encourage you guys to use Git and GitHub to track those changes. It's a lot of manual stuff and discipline to follow through, but it pays off in the future. The more comfortable you get with it, the easier it's going to be to work with teams and future things that branch off of the same concept. Last, I think, topic, we don't want to ignore the .git ignore file that I mentioned earlier. So this .git ignore file is a hidden file that we list files and folders we don't want to commit. So commonly we don't want to commit environment variables or environment files, private credentials, logs, cache, settings, etc. Typically you can do a quick Google search online to see what your tech stack commonly ignores. So like for example Java, you commonly don't commit your class files at a minimum. For Node.js, JavaScript frontend projects, whatever, you typically don't commit your node modules folder. PHP, I don't recall off the top of my head, unfortunately. We don't commit environment variables. But anyway, so we want to usually set this up for a project. Depending on what we're doing, we don't want to include certain things. You can also do partial match for things too. So let me quickly demonstrate this. So I'll do this in a second. It doesn't matter. So I'll do nano .git ignore. That's going to create a file. So let's say I have a .env file for environment variable. I don't want to mistakenly commit that. If we commit private credentials to GitHub, it can be bad because if our GitHub is public or becomes public or gets compromised, there goes our private credentials. It has happened, and GitHub is taking certain precautions to kind of try to detect if you share private details. I don't know if it's out of beta or alpha yet, but there is something coming to help let you know at least. But you want to be careful. And if you ever do mistakenly commit private credentials, make sure you change those as soon as possible and resolve it. So anyway, I'm gonna have this here. I'll save the file. And right now, if I do git status, we have the new file changed, whatever. If I make that env file, it's not going to show up right now because it's now ignored. You can use git status -- ignored to see that file, ignored files. Now, you can have any number of things line by line that you want to ignore. File names, folder names, as I said, paths, partial matches. Let's say I didn't have the .env. If I do git ignored, if the file doesn't exist, it's not going to show up. It doesn't mean it's not working. It just means you don't have a file worth mentioning. So I'm going to make that file again. If I do git add dot, we can see git status only has the .git ignored. That means I can't add .env. I could force it. I can do git add whatever -f to force it, but obviously you don't want to do that because you don't want to track your private details. If you've already tracked a file and then you added a git ignore, then you have to do git rms cache or the unstaged stuff that I showed earlier in the slides. I can actually demonstrate that with my test file. So git restore staged test.git. Let's see if this works now. Status. Okay. So let me see if that's going to actually work. I'm going to do git add. Git commit. FM adding .git ignore unstaged. Oh, that's .git. Okay, let's see if this works. Git push. Git push origin. Okay. I'm going to go back and take a look at that branch. Okay, so it didn't unstage whatever it was looking for. Okay, I don't know. I usually use git rm-cache, so I haven't looked into restore stage. I haven't read about it, but supposedly it says you can restore the stage file, I guess, to unchange it. Anyway, git rm-cache is a way to kind of untrack it so that if you mistakenly added it already or it is already being tracked, you can stop tracking it. Now let's go back, and I'm pretty sure we're almost done. Yeah. So after that big marathon, it was longer than I anticipated, so I guess when I presented it, I had to get in 60 minutes, and now I updated to get in 90 minutes, and that's still wrong. But anyway, that's the gist of dealing with Git and GitHub. We covered quite a bit about Git and GitHub in a relatively short time span. There is a lot of other practice and reading and exploration we can do. I do recommend you guys to do that on your own. Of course, there's plenty more to learn, as I said. We have a lot of documentation and things. It's good to be comfortable with most of what can be done, especially when you're in a team. There's a lot that can kind of go wrong if you don't follow the proper steps, and only then will you really kind of need to, of course, research how to undo that. But what I went over in this presentation is the minimum to kind of get started with using Git and GitHub. And as you use it, you'll read more about it, and you'll be more comfortable with the different alternatives. And you'll be able to form your own opinions or your own ways of using these tools rather than just going based on what I said. What I'm saying is just one of many ways you can deal with things. There's a lot of overlap in a way with how to use it, so it's flexible for various team styles or usage patterns or whatever. But some things to keep in mind. Git can only track changes. If something doesn't change, it's not tracked. It's just whatever it was when you last tracked it. Always do add, then commit. You can't commit without adding. Adding tracks it, committing confirms it. Push to sync to your remote, your origin. Pull to sync to local. Do your best to avoid merge conflicts. They're not a lot of fun to deal with, especially in large projects. When we git ignore proper files, like node modules or vendor folder for using PHP and Composer, other things that aren't your own, you want to make sure you don't add those to your repository because they can be a source of merge conflicts. That remind me of something important. I will go back temporarily to kind of not fix something, but help save you guys some hassle. Practice to be attentive. Practice and be attentive with your commands. Be sure of what you're doing. Don't just blindly run things. Read your output. If you get output, usually that means something didn't work in Unix commands. Sometimes it gives you status updates, but usually if you have output, it doesn't mean it worked. Commonly, I get questions in the beginning. People show me errors, and they're like, "Did it work?" It's like, no, it didn't work because it's telling you an error there. So make sure you read your messages, and usually it will try to kind of help you, or at least it will give you something that you can Google to kind of try to figure out what's going on. Don't be afraid to Google things. You can only merge two branches if there are changes to merge. We already saw that, so just highlighting that. And of course, don't panic. Don't do things in a panic. Stop as early as you can as soon as an error happens. Read what the output's doing. Um, Look online to read about what causes it and whatnot. Don't just type commands to type commands. The worst thing you can do is to just keep typing things and further messing things up. Now, of course, there's a limit to what you can do, but try not to further dig your hole, so to speak. The one thing I want to highlight real quick is related to the .git ignore. So .git ignore. Macs have this wonderful file called .dsstore. Basically metadata about the folder. This is a binary file, if I'm not mistaken. If you have this tracked on GitHub, it is one of the most common sources of conflicts. And it's not something you can really resolve visually because it's binary. I don't know about you, but I can't read binary at a glance like that. I mean, well, whatever it gets converted to. So you're not really going to be able to resolve that conflict other than removing the file. So .dsstore is a common file to ignore. It's helpful to ignore on Windows machines too, in case you work with anybody with a Mac or whatever, but dsstore is another common thing to not track. Just a quick rundown, so if you're using Python, if you're PyCache, you don't want to track, oops, I'm going to do that. Anyway, if you're doing PHP, you have your vendor, keep hitting the wrong key, but whatever. I'm not going to save this, but node modules, I think it is. I don't know why I keep doing shift enter. I don't know where that command is coming from at the moment. Anyway, so you'd list out things like that. You'd have your class files for Java. You have, I don't know, anything else that's not really human readable, you typically don't want to add to GitHub. Of course, you can add your final compiled version of things if your program compiles. That way you can share it. But usually you have the build tools available and people rebuild it on the machine or something. Right. So hopefully that helps you guys in future classes, future projects. If you guys have any questions, you can just reach out to me. I'm on the Discord related to this presentation, which is Google Developer Student Club for MJT. Or if you're in my class, you already have my Discord, or you can email me. You already saw my email address a couple times here, and I'll be happy to help guide you through other things, answer some questions. Um, but never stop learning about these topics. If you feel like you know it all, keep digging. You'll find something new. Things are constantly changing, as I already showed you. So what you know now might not be the same in a month from now, a couple months from now, etc. The standard concept will be the same, but how to do it might change a bit. So definitely don't just stop learning. Just like your programs, keep your knowledge up to date. So thank you for watching, and thank you for attending if you attended live, or at least just watching this video. And I'll see you guys in a future workshop, presentation, or class or something. Take care. Thanks again.